this is GCSE Papers, Shadow Set 1, Higher Tier Paper 2, Thursday 6th of June 2019. So this is a video to go through all of the answers from start to finish of this paper. I will briefly explain, but not in detail each question, so there will be more in-depth explanations for some of the questions if you look up some of the other videos. Okay, so as this is paper 2, it's a calculator paper. Remember, calculator paper. You need to make sure you use a calculator appropriately. Okay, I will have used a calculator on many of these questions. Don't forget to use a calculator. Okay, so question 1. Question 1 is solving an inequality question, and you solve these exactly the same way as you would solve an equation, except for it doesn't have an equal sign, it has an inequality sign, such as a greater than or a less than sign. So solved exactly the same way as solve an equation, and the answer is n is greater than 3. Part B is to represent an inequality on a number line. So again, we've got this inequality, and it's a double-ended inequality. So I've similar technique to solving an equation. I've taken away 3 from both sides, and I end up with -6 is less than x, which is less than or equal to 2, which is represented on the number line like this. Solid circle, filled in circle, because it is less than or equal to 2. So when it's filled in, it means it can include the 2. Empty circle means it doesn't include the -6 because it doesn't have the equal to part on here. So question 1, inequalities, solving, representing. Question 2 is drawing a straight line graph. We know it's a straight line because it doesn't have x squared or x cubed or square root of x or anything like that. There's a few different ways you can do this. The first way is I've drawn a table of values. My x values go from -2 to 4, just as it says in the question, and I've just worked out all the relevant y values. Y is equal to 2 times whatever x is, take away 2. For example, 2 times 4 take away 2 is 6. 2 times 3 take away 2 is 4. 2 times 2 take away 2 is 2, and you can begin to see the pattern is d for every one x value, we're dropping down by 2 in the y value. I started working out with the positives because it's much easier to deal with positive numbers than it is negative. It's a straight line graph, so that means that you will get a straight line, and by that I mean that when you put your ruler down, it will form one straight line that you could do in one single movement. Okay. There are a couple of other ways you could do this question, or definitely one other way you could do this question, and that would be using the gradient intercept method that you may well be aware of. In that case, y equals 2x take away 2. This represents the gradient, and -2 represents the y-intercept, and so you can use that as our y-intercept, we know is -2. And because the gradient is 2, it means that if this is our y-intercept, for every 1 unit along we go, it means we'd go up 2 because the gradient is 2. So along 1 unit, be very careful of the scale. They're different in the x direction to the y direction. So we know that was the y-intercept, 1 unit along, 2 units up. That would be the next point. 1 unit along, 2 units up, next point. 1 unit along, 2 units up. 1 unit along, 2 units up, and we can draw a line. Remember, it needs to go from x being -2 to x being 4. So it goes from this point all the way along to this point. Okay, straight line graphs. Question 3, some sampling. So you needed to work out how many of the 165 students wanted to go to the theme park. Well, 10 of the 30 that were asked in the sample said theme park. So we're going to assume that proportion remains the same for the 165 students in total. So these were in the sample of 30, and we want to know how many out of the 165 would go. So 10/30ths of 165, of means times 10/30th times 165, 10/30 is also the same as a third. So a third of 165, 10/30 of 165. Either way, the answer is 55. And the assumption, I've assumed that the sample is truly representative of all 165 students. Otherwise, the 55 estimate could be too high or too low. For example, if Naomi had asked 30 students, she just asked her best friends or something like that. It wouldn't give a true representation of the whole 165 students going on the trip. Okay, so that was my assumption, and that was what would have happened if this assumption was incorrect. Okay, next question, number 4. Number 4, we've got a container in the shape of a cuboid, 60 centimetres 12 by 38. So you can see how the full volume of the container, so the full volume of the cuboid is length times width times height. That would get you 1 mark. It's 2/3 full of water, so 2/3 of the full volume, divide by 3 times by 2. Then you need to know this little fact. Sometimes people forget this little fact, that 1 milliliter of water has a volume of 1 cubic centimetre, 1 centimetre cubed. So therefore, this value here, 18,240 centimetres cubed, must mean there's 18,240 millilitres of water in the container. So we know that. And then all you need to do is see how many 275 millilitre cups you can get out of the 18,240. So do a division. Doesn't come out to be a whole number. 66.327 recurring. It means you can get 66 full cups. 66 full cups. Okay, question 5. Some trigonometry. SOHCAHTOA. Labelled it opposite, hypotenuse and adjacent. Basic triangles, more in-depth formula triangles. You've realised that you don't need the adjacent, it's the opposite you're trying to find, and you know the hypotenuse. So opposite and hypotenuse is a sign question. So you can see here, if we're going to try and find the opposite, sine of the angle multiplied by the hypotenuse, because they're next to each other. Sine of the angle multiplied by the hypotenuse. Sine 38 times 18, 2 decimal places, 11.08. Number 6. So this is really important here, that this question is not the same as one of the ones that says an answer has been rounded to 9.5. What's the lowest and maximum value it can be, right? It's not the same. It tells you that this calculator, Jenna used her calculator to work out a value of number 1. The answer on her calculator began 9.5. So it said 9.5 something. Could have said one of these things that I've written here, or anything else that started 9.5. Okay, so if it started 9.5, then it could have been 9.5 0.00000001, right? But it could have been anything as low as 9.5 itself, but it had to be less than 9.6. Okay, so those were the 2 values that you needed here. Okay, if you're unsure about that, because this did cause significant problems in the exam in 2019, there was a lot of pupils getting this incorrect, right? Putting 9.45 and 9.55. It's a different type of question. Look up truncation. Look up a video on truncation. Okay, you'll find many videos and many examples. Okay, number 7. Number 7, a ratio question. So we've got 450 is shared between A, B, C, D. Okay, Amanda and Bernard shared it in the ratio 2:7. Colleen and Dawn got 1.5 times the amount that Amanda got. So that's the full ratio. A, B, 2:7 to 3:3. C and D got 1.5 times whatever A had. So 2 times 1.5 is 3. Okay, so that's where that came from. And then it's just a case of dividing the ratio in the dividing £450 in the ratio 2:7 to 3:3. So 450 divided by 15, because this adds up to 15, and then times by 7 means that Bernard got £210. Question 8, some standard form questions, relatively straightforward. 4.67 times 10 to the power minus 3 and 1.547 times 10 to the power 3 is 1,547. Number 9. So circumference of circle B is 80% of the circumference of circle A. Find the ratio of the area of A, circle A, to the area of circle B. Well, circumference of B as a ratio, if B is 80% of A, if this was 100, this would be 80. Okay, if I think about things with 100% and just pick a number of 100, it means things are going to be able to be worked out. Okay, much easier than had I picked any other number. So this is 80% of this, right? So this is the ratio, 100 to 80 in terms of the circumference. I've simplified the ratio down to 5 to 4. All right. Now, you need to know this to do with your scale factors. An area scale factor is the linear scale factor squared, okay? Or the length scale factor squared, the linear scale factor squared, the length scale factor squared. So an area scale factor is the length scale factor squared. So therefore the area of A to the area of B, 5 squared to 4 squared, 25 to 16. Okay, and you're going to use this formula again, but the other way round in part B. So part B, area E to area F, again, it says the area of E is 69% greater than the area of F. Well, if area of F, if we say it's 100, then E would have to be 169, 69% more. Okay, and using this, but going in, using this formula here, but going in reverse. So we've got the area. We want to go back to the lengths because E to F is about the lengths. Then we can square root, and the square root of 169 and the square root of 100 is 13 and 10. So the answer is 13 to 10. Question 10, a probability tree. So we need to complete the probability tree. So all you needed to do was put these numbers on the, decimals on the probability tree to get the first mark. We know that each set of branches, individual set of branches, has to add up to 1. So 0.25 and 0.75 adds up to 1. Same thing on the Friday, because it says that any day probability the train will be late is 0.25. And you can see I filled in all the probabilities over this side as well. So probability late both days is 0.25 times 0.25, 0.0625. Late, not late, 0.25 times 0.75. Not late and late, 0.75 times 0.25. And not late on both days, 0.75 times 0.75. So you then had to use some of that knowledge, some of those answers for part B, and that was to work out the probability that the train was late on at least one of these days. So if it's late on at least one day, it means it's either late both days, or it's late on the first day but not late on the second day, or it's not late on the first day and it is late on the second day. So late is 0.25 times 0.25. I've already worked that out up here. Okay. Late and not late, 0.25 times 0.75. Again, already worked that out up here. And not late and late, 0.75 times 0.25. Again, already worked that one out over here. So add them up, 0.4375. Okay, I've written both two methods down. This one you can see is a lot quicker because the question says work out the probability a train will be late on at least one of the days. Well, I've said if you take away the probability that it's not late on either day, then you're going to be left with the fact that it's late on at least one day. So 1 minus the probability of it being not late both days gives the exact same answer and is actually a lot less work. Okay, but do whichever method you feel most comfortable with to guarantee you pick up these 5 marks. Okay, question 11, cumulative frequency. So you're given a table here about the times in minutes that 80 office workers took to get to work. So 5 people took between 0 and 20 minutes, 28 people took between 20 minutes and 40 minutes, 18 people took between 40 and 60 minutes, and so on. Cumulative frequency is where you're adding up as you're going along. So between 0 and 20 is the same, 5. 0 and 40 means it's all of these people plus all of these people, which is why it's 33. 0 and 60 means it's all of these people, all of these people, and all of these people, which is why it's 51. This plus this plus this. 0 and 80 is 66 because it's this one, this one, this one, and this one. 0 to 100 is 76 because it's this one, this one, this one, this one, and this one. And 0 to 120 is all of them added up because it's all of these ones, because it covers everyone, and that's 80. And you should always find that that will match the number that you're usually given in the question. Okay, so 1 mark for being able to do a cumulative frequency. Then plotting the cumulative frequency curve, you need to use the table that you've just filled in, and remember you are plotting at the end of the group. So for example, we're using this table, 0 to 20, the end of the group is 20, the cumulative frequency is 5. So I go along to 20 and up to 5. The next point that I need to plot is at the end of the group, 0 to 40 and up to 33. So I go along to 40 and up to 33, and that's where I've plotted my next point. Right, and the reason that you go all the way along to 40 is because you are including all of the people up to 40. Right, we're not just going to put something in a midpoint somewhere, we're including everyone who took up to 40 minutes to get to work. So that's why we go all the way to the end of the group. Okay, so the next one will be along to 60 and up to 51. Then it will be along 80 up 66, along 100 up 76, and along 120 and up 80. And that's the curve that you will get. Okay, so this line is part of the next question, but there's our curve, 120 and 80. Okay. Then we need to use our graph to find an estimate for the percentage of these office workers who take more than 90 minutes. Okay, so I've used my graph, I've gone to where 90 minutes is, up to my line and across, right? And all of these people here, 2, 4, 6, 8 people, right? They took more than 90 minutes. All these people down here took less than 90 minutes. So there's 2, 4, 6, 8, looking at the scale. 8 people took more than 90 minutes. So as a percentage, that's 8 out of 80 times 100, that's 10%. Okay, now I know that the mark scheme allowed anything between 8 and 12% as a final answer. Not 8 and 12 for here, but 8 and 12% as a final answer. Okay, so you need to be really accurate with your curve, and you need to be really accurate with your straight line with a sharp pencil and a ruler. Okay, moving on. Question 12. Question 12, we've got a sector of a circle. So you can see the area of a sector, theta over 360 times pi r squared. So I've called that angle x rather than writing theta. We know that x over 360 times pi times 7 squared is 30. It tells us what the area is in the question. And then I've just worked backwards to find out what the angle x is, and it is 70.15809.736. Okay, so it's not to scale, definitely, because that's clearly more than 70 degrees. But this is what the maths is telling us. Yeah. So we now know this angle. It is just over 70 degrees, but you shouldn't round this. Don't put 70.2 and then use that, because we're continuing to use this number. So we'll keep using that as we go through the question. Okay, because what we need is the arc length. So here's the formula for arc length. Theta over 360 times pi d, or if you prefer to use circumference of a circle as 2 pi r, then it'll be theta over 360 times 2 pi r. Okay, this is just for the circumference of a circle, because the arc is part of the circumference. Okay, so arc length, the angle out of 360 times pi times the diameter, or the angle out of 360 times 2 times pi times the radius. Same thing. Either way, there's the arc length. And we wanted the perimeter. So the perimeter means 7 plus this arc length. So 7 plus 7 plus 8.571428. We'd get the perimeter being 22.571428. And to three significant figures, it'd be 22.6 centimetres. Okay, question 13. A lot of algebra involved in this one. So we need to show that this simplifies to ax take b over cx take d, where a, b, c and d are whole numbers, are integers. So I've started by just looking at the bit in the square brackets. Okay, so x plus 4 I've written as x plus 4 over 1, because I'm going to be dealing with a lot of fractions work. So if I write that as a fraction, it's going to make things easier. And then I've factorised, this is a quadratic expression. It's a quadratic expression, and I've factorised it. Okay, because things are going to cancel out, and the more you see these questions, the more you begin to recognise that you know something's going to end up cancelling out in brackets in a fraction. Okay, so I've factorised that. I've got this. Okay, but because it's a fraction division, I've flipped this upside down and changed it to a times. So we end up with x plus 4 over 1 times by x take 1 over x plus 4 x take 2. And then, knowing that I can do some cross cancelling when I'm multiplying fractions, x plus 4 cancels with x plus 4. Okay, so now I've got 1 over 1 times by x take 1 over 1 times x take 2, or simply just x take 1 over x take 2. Okay, so that whole bracket, that whole square bracket simplifies to this. So now I've got to do 6 plus this. So 6 plus x plus 1, 6 plus x take 1 over x take 2. Again, if I write the 6 as a fraction, I can then use the so-called butterfly method. So, which is what I've done here. I've done 6 times x take 2 plus 1 times x take 1 over 1 times x take 2. Okay, multiply out these brackets, 6x take 12 and 1x take 1, and that's an easy one to multiply, it's just a 1. And then tidy it up. 6x plus x is 7x, 6x plus x is 7x, and minus 12 take away 1 is minus 13, and there's our final answer. It's in the form ax take b over cx take d. Whole numbers, done. Okay, question 14. So a car moves from a rest. The graph gives information about the speed in v meters per second of the car t seconds after it starts to move. Right, so just before I go any further, there's a lot of stuff I've drawn on this graph, and some of it relates to part B on the next page. Okay, so the first part says calculate an estimate of the gradient at t equals 15. So the first thing you need to do is work out what the gradient is where the time is 15. So what I've done is I've drawn a tangent to the curve. I've drawn a tangent at t equals 15. So there's the curve. There's my straight line, a tangent to work out the gradient at that point, an estimate of the gradient. So I've drawn that, and all I need to do is work out the gradient of this line. So I've just done this divided by this. Oops, I've just done this divided by this. That's why I've drawn my right angle triangle. Doesn't matter where you draw the right angle triangle, the gradient will be the same on this straight line. So I've just picked these points, and I've worked it out to be 15 divided by 10, because my triangle is 15 up, 10 across. Some people may say rise over run, rise over run. Some people may say change in y divided by change in x. Some people may just say up divided by across. Okay, either way, in this case I've got 15 over 10, and my answer is 1.5. And the mark scheme says anything between 1.5 and 2. So I suppose I was actually only just inside, but I am inside, and that's fine. Anything between 1.5 and 2. Second part, this one says, describe what the answer to part 1 represents. Well, it's the acceleration. The gradient always represents a rate of change, okay? And in this case, in speed time, that it represents acceleration. So it's the change in speed in relation to time. So the answer is simply just acceleration. Would have done one word, would have got the marks, acceleration. Now the next part is something called, what's called the trapezium rule, okay? Now, if you look this up, be sure to type trapezium rule GCSE, because it comes up at A level at the end of the first year, possibly even the second year of A level, okay? The trapezium rule. So if you look this up, type trapezium rule GCSE. So the area under a speed time graph is equal to the distance travelled. Okay, so what you need to do is work out the area under the speed time graph between up to 20 seconds. Okay, so that's where all my other little lines came on. So it says use 4 strips of equal width, right? So I've gone up to 20 seconds, 1 strip, 2 strips, 3 strips, 4 strips. And all you need to do is work out this area. Now it's an estimate, because all I've done is drawn these straight lines. So this becomes a shape with straight edges, a polygon, right? So this becomes a triangle, and then these, trapezium, 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 which is why it's called the trapezium rule. Okay, allows us to estimate the area under a curve. Okay, so first one was a triangle, and then these are the areas of those next 3 trapeziums. Okay, and so the answer is 440 meters. Okay, next question, number 15. Make P the subject of the formula. So I want to get rid of the fraction first by multiplying both sides by n plus 1. Multiply out the brackets, get everything involving what you want to be the subject on one side of the equals, and everything not involving m on the other side of the equals. Everything involving m on this side, everything not involving m on this side. It doesn't matter whether you put it the other way round, okay? Sometimes it makes it easier, and the more you practice these and the more you do these in lessons, the better you'll become at making the decision as to whether you put them on the right hand side or the left hand side, right? But as I said, we want m to be the subject, so we want everything involving m on one side and everything not involving m on the other side. And then we can factorise it, because we've got these 2 m's, now we've only got 1 m, so it's factorised. And then once we've done that, so I've just written it out again so it just follows through, we can divide by the bracket, and now we've got m on its own, so m is the subject of the formula, and this is the answer. Okay. 16. Question 16. We've got this straight line, 3y equals 5x plus 8, and you've got point A as the coordinates 3 minus 6, and you need to find an equation of the straight line that is perpendicular to this one and it passes through that point. Okay, so this line, if I put it in the form y equals mx plus c, y equals mx plus c, right, I now know this is the gradient. That's the gradient, remember? So 5/3 is the gradient of L. And then the perpendicular gradient, flip it upside down and change the sign, is just minus 3/5. So I'm beginning to get there. So what I say now is the perpendicular line has the equation y equals minus 3/5 x plus c. We just need to work out what that c is. We know it passes through this point, so we know that when x is 3, y has to be minus 6. So I can just sub those values into this. I can sub in y for minus 6, or minus 6 in for y, and I can sub in 3 in for x. Okay, and then I've only got one unknown. Done that down here. So we've got this. Remember, calculator paper, so there's no need to be concerned about fractions and negative numbers or anything like that. Calculator paper, minus 3/5 times by 3 comes out to be this. add 1.8 to both sides. C is minus 4.2, so there's my answer. Okay, occasionally you can be asked to write that in a different form, right? You know, this is in the form y equals mx plus c. Sometimes you can be asked to put it in a different form, so I've just written that here. You can multiply it by the 5 to get rid of the fraction, and we end up with 5y equals, mistake. It says we're going to end up with 5y equals minus 3x minus 21, and then if I rearrange it I would get 3x plus 5y plus 21 equals 0. Do apologise. Okay. Moving on, question 17. Oh, by the way, either of those is fine in this case. Question 17. So we've got some bit of problem solving involving ratio. So we know that there's some cubes, some small cubes and some large cubes, and some of them are red and some of them are yellow. The ratio of small to large is 2 to 3, and the ratio of red to yellow is 4 to 7. Why is the least possible number 55? Well, it's because the lowest common multiple of the combined simplified ratio is 55. 5 and 11, 5 times 11 is 55. They won't go into anything else. That's the lowest number that those 5 and 11 will both go into. Okay, so 55 is the lowest number, or the least possible number of cubes in the bag. Okay, and that is important for the second part. You need to use that at the start of part B. So there must only be, so it's to work out the least possible number of large yellow cubes. So if we're talking about the least possible number, it means we're talking about the 55 cubes. Okay, so we know the small to large is the ratio 2 to 3, and when that is 55 is divided in this ratio, we'll get 22 and 33. Okay, so there's 22 small cubes. It tells us here all of the small cubes are yellow, so therefore there's 22 yellow small cubes. Okay, red and yellow is in the ratio 4 to 7, and when we divide 55 in the ratio 4 to 7, we get 20 red and 35 yellow. Okay, now if we know there's 22 small yellow and there's 35 yellow in total, then there must be 13 large ones. 22 small, 13 large. 22 small must be 13 large. Okay, and that's the answer to the question. There are 13 large yellow cubes. Okay, number 18, circle theorem question. So we've got the information. I've already answered this, so I've already put on some of these numbers here. Okay, circle theorem question is really important that you put your reasons. It's a 5-mark question. If you don't put your reasons, so the maximum you get will be 3 marks. You need the reasons. Okay, if you can get the numbers, then you must know the reasons, right? If you can't get the numbers, you don't know the reasons. But if you get the numbers, clearly you know why you got them, so you must know the reasons. So get them written down. Okay, so the first thing I did, I wrote those 275s in. Okay, so I wrote that BAE, I really mean BAD, I mean that BAD equals BDA. Okay, they're both 75, and that's because angles at the base of an isosceles are equal, and angles in a triangle sum to 180. You need them reasons, right? This is an isosceles triangle. We know that because of these two little markers. So 30, 75, 75 gives us the 180, and these two are the base angles of the isosceles. Okay, next thing I've done is I've found angle BCD. Okay, and I've said that that is 105, and I've said that's 105 because opposite angles in a cyclic quadrilateral sum to 180. And if we look here, we've got a quadrilateral inside a circle where each one of the vertices touches part of the circumference. When we have that, the opposite angles will always add up to 180. Okay, so if we know this is 75, this one here has to be 105. Okay, has to be 105. Okay, next part, I've found CDB, which is 180, take away 105 divided by 2, which is 37.5 degrees. Again, that's because this is an isosceles triangle. This length is the same as this length. This is 105, so 105 taken away from 180 and then half it, well, means that these two angles are both 37.5. Okay, and then all we've got to do is find angle ADE, which is the final part, which is what the question wanted us to find, and actually nothing to do with circles anymore. This is just a straight line. CDE is a straight line, so this angle, and this angle that we're trying to find add up to 180. Okay, so 180 take 75, take away 37.5 is 67.5. Angles on a straight line sum to 180, right? These reasons that I've written down, you need them, okay? You can't get 5 marks if you've missed any one of them reasons, okay? And as I said, if you can get the numbers, you must have known the reasons. Okay, number 19. Number 19 is a 3D Pythagoras and 3D trigonometry question, starting off with a bit of ratio. So we know that we've got ABCD, the base of the prism is a square of side length 15, so 15 and 15. We've got the right angles, ABE and CBE, so it's telling us that there's some right angle triangles going on. The fact it's a square is also telling us that there's all these angles on the base would be right angles. And we know that angle EAB is 25, it's given on the diagram. It tells you that M is the point on DA such that DM to MA is 3 to 2. So there's DA. I've just put in M roughly in the right place, 3 to 2. And then I've divided 15 in the ratio 3 to 2 to give me the specifics. So DM is 9 and MA is 6. Okay? Put that on the diagram. And what we need to do is find the angle between EM and the base of the prism. So there's EM. And the base of the prism is this flat plane across the bottom. All right, so this is just step by step. Step by step, this is just 2D trigonometry or 2D Pythagoras. Okay, and you'll notice I've drawn out each of the triangles individually from different viewpoints. So first thing I've started with is, can I find length BE? So can I find this length here, right? And I can find that by just looking at triangle ABE as a 2D triangle. It's a right angle triangle. ABE, 25, 15, I want to find that. Sine, cos, tan. It's a tan question because I'm dealing with opposite and adjacent. It's a tan question. I'm trying to find the opposite, so tan of the angle times by the adjacent, and you end up with BE is 6.9946, and so on. Okay. Next thing I've done is I found length BM. Okay, the point from there to there. Okay, BM. So we have MA is 6 and AB is 15, right? So this is now looking sort of a plan view, a bird's eye view of here, this triangle MAB as a bird's eye view of it. Okay, and it just becomes a very basic Pythagoras question. 6 squared plus 15 squared, square root it, square it, add them up, square root it, and we get 16. That BM is 16.155. Okay, and now I just need to find that final angle that was angle EMB. So we're trying to find the angle between here, when you go from here down to here and across to there. And that'll give me the angle between EM and this base, the plane. Okay, but again, it's just about a 2D triangle. So going from M up to E and down to B, I found those two lengths in the first part of the question, 6.9946 and so on, 16.15549 and so on. All right, and this is the angle I need to find. So again, it just becomes a sine, cos, tan question, and we're dealing with opposite and adjacent again. We're dealing with opposite and adjacent again. So it's a tan question. We're finding an angle, so you always need to press the shift button. You need the tan -1, opposite over adjacent. The angle is 23.410 and a bit more. So to 1 decimal place, which is what it asks, it's 23.4 degrees. And finally, question 20. Now, question 20 is a vectors question, and this is a proper grade 9 question. If grade 10 existed, this would be on the verge of grade 10. Okay, this is a tough question, right? We had to, the first thing, 2 marks. First part is actually not that hard at all, okay? And this is actually really common in vectors questions, that the first part is more than achievable by every single person doing it, okay? And it's worth 2 marks. The whole thing is only worth 6. These bits, this bit here, really will probably take a minute and a half, okay? Everyone can do this. So you need to go from F to E in terms of little a and little b. So F to E, here to here, right? We don't know what that is yet. That's what we're trying to work out. But we do know what this is, we do know what this is, and we do know what this is. It tells us that D to E is the little b. So I've not written that on there because the M's kind of blocking it in a way. So it's this, this, and this. So F to E means we go from F to C, then from C to D, and then from D to E. F to C, we're told in the question, is A take away B. C to D, we're told in the question, is A. And D to E, we're told in the question, is B. So just add them all together. So we've got our A take B, add our A, add our B. And it's just done like any old algebra. A plus A is 2A, and we've got a minus B plus B. They cancel each other out, and you're left with 2A. Done. Now, part B is a significant step up. It tells you that M is the midpoint of DE. So M is the midpoint of DE. That means that's halfway up. So therefore, D to M would be half of B, and M to E would also be half of B. Same direction, okay, just half the length, half the distance. So we know that X is the point on FM, such that F to X to X to M is N to 1. So F to X to X to M is N to 1. Okay, so that means this total length, we could call it N plus 1. N plus 1 for the total length FM, or the total length MF. And it also says that CXE is a straight line. CXE is a straight line. You need to work out the value of N, okay, that would make it so that that puts that in a straight line, okay? So this bit here is absolutely crucial. If vectors are parallel, then they must be multiples of each other, because of the, it means that if they're multiples of each other, they must be going in the same direction. Okay, and if some things are going in the exact same direction, they must be parallel. Okay, so we know that CE is A plus B. We know that, so CE, A plus B, A plus B. We know that FM, so I'm working this out, is going to be going from here to here to here to here. Okay, so FM is A take B plus A plus half of B, which simplifies to 2A take half B. But also MF, if it's in reverse, switch the signs. So instead of being minus half B, it'll be plus half B, and instead of being positive 2A, it'll be minus 2A. Okay, so FM is this and MF is this. Okay, so as I said, if vectors are parallel, they must be multiples of each other. So the way I'm approaching this question is I'm working out what CX is, and then I'm going to work out what XE is, and they must be multiples of each other. Okay, so we've got Cx, so is CD plus dm plus 1 over n plus 1 of mf. So Cx is this plus this little bit. Okay, so CD plus dm plus 1 over n plus 1 of mf. Okay, 1 out of n plus 1 of this whole length in that direction, because I'm choosing to go from there to there and then to there. Okay, so A plus half B plus 1 over n plus 1 lots of mf, and mf I did it there. Okay, simplify it. So I've multiplied out the bracket, becomes B over 2n plus 2, take away 2a over n plus 1, and then I am putting the component of A with A and the component of B with B. All right, so essentially what I'm doing is factorising that previous expression, right, and taking the A's out and taking the B's out. Okay, and we end up with this. Now then you want to get this simplified as much as possible. So instead of having 1, I've written it as n plus 1 over n plus 1. Now that skill I'm going to use many times throughout the rest of this question. Okay, so n plus 1 over n plus 1 is 1, and 2 over n plus 1, because now I've got both of them as fractions over n plus 1, which you can see now means they can have the same denominator, and then I can end up with n plus 1 take away 2, and n plus 1 take away 2 is just n take away 1. So this, and this are all equal to each other. That is the same as that, which is the same as that. Do the same thing with the b's. Okay, so I want to get them so they're both fractions with 2n plus 2 as the denominator. So n plus 1 over 2n plus 2 is a half. This is a half of this, so therefore this bit here is the same as a half. All right, but I've now got the same denominator, which means I can put them both over 2n plus 2, and then I end up with n plus 1 plus 1, which is n plus 2. And now that looks a heck of a lot easier to deal with than that. Okay, now then we need to do the same sort of thing with xe. So I'm just going from x to e, and I'm doing it by going from there to there to there, okay, because I'm dealing with mf this direction. In the first part I'm going to carry on, so I'm going to do that plus that, so get from x to e is that plus that. So done the same sort of thing here. Okay, and I've just used those same skills, those same techniques. They're very high level, all right, but I've just used the same techniques as what I've used in the first part. So I've just multiplied out the bracket, then I put all the a bits together and all the b bits together. Then I want to get them so they're fractions with the same denominator, because it makes it easier to deal with. So in this case I've changed the 2 to 2 lots of n plus 1 over n plus 1, because they'll cancel out. Okay, and it's the same. I've now got that all over n plus 1, which simplifies to this, and that looks a lot easier to deal with than that. Okay, so that one sort of all followed through. I've now got this. So I now know that Cx from the first part of my working, so Cx is this. So there's Cx from earlier. So Cx and xe. Xe is what we've just worked out. So we've got this. We know that Cx is this and xe is this. Okay. And now, if these vectors are parallel, then the coefficients of a and b for Cx and xe they would have to be in the same ratio. Okay, they'd have to be in the same ratio. For example, if I go back to, if I just do that so you can see them both, right? There you go. So what I've done is this divided by this must be equal to this divided by this. Okay, I'm keeping things in the same ratio. Now you can do that in the other way around, doesn't make any difference. this over this must be equal to this over this. Okay, because it keeps the ratio the same. So this 2 over n plus 1 divided by n take 1 over n plus 1 must be equal to n over 2n plus 2 divided by n plus 2 over 2n plus 2. And then it's an equation, right? And I say that like, oh, it's just an equation, but it's an equation and you can deal with it. Okay, so it's a division, so I've changed it to times and turned it upside down, both of them. And then you can begin to see things start happening. They both cancel out, diagonal cancelling. They both cancel out, diagonal cancelling. So I'm now just left with this, 2 over n plus 1 equals n over n plus 2. And now I can do some diagonal multiplication. This times this times this, 2 times n plus 2 must be equal to n times n take 1. Multiply the brackets. Begin to see we've now just got a quadratic. The quadratic factorises. 2 solutions, n equals 4, n equals minus 1. However, in this case, this specific question, n can't be a negative number. N must be positive, so therefore n must be 4. Now, like I say, that is a exceptionally challenging question, okay? And there will be many, many different ways to do that. That's just one way.